The Palmdale Bulge is moving, and it's bulging. It is thought to be the precursor of future earthquakes in Southern California. The central circle there is Palmdale. And we've had Ventura earthquakes quite big recently, north of Los Angeles. Palmdale's about 50 miles northeast of Los Angeles, located between the San Andreas Fault, not far from the Garlic Fault, as we know, that has been jolted very heavily since the Crest earthquakes. And I thank Shirley Williams for reminding me of this. She just left a comment on the bulge of the Palmdale. It's bulging, she says. And I thank her for that. Now, what is the Palmdale Bulge? The USGS geologists that went back to investigate this is from decades ago, in the mid-70s, early 80s. The teams were sent out to see what this bulge was all about. This was before GPS, Geodesy. And we're going to look at the Geodesy, the GPS, and the deformation, the movement of that area, so you can see for yourself today what's taking place. Is it moving? Is it bulging? Is it deforming? Is it subsiding? Everything is going on there. And we'll take a look at that together. But what is this Palmdale Bulge? According to Dr. David Jackson, professor of UCLA Department of Earth and Space Sciences, this was back in the 1980s. He says that it was thought to be, I don't know what the situation is today, the precursor of some future earthquake in Southern California. It's a 32,400 square mile fantasy, an artifact, and even though over $3 million at that time were spent studying it. Of course, we said that they did not have GPS. They did not have geodesy. The bulge, he says, was created by errors in measuring equipment, and Dr. Robert Castle, geologist at USGS, who discovered he discovered an uplift in the area in 1976 along about 400 miles of the San Andreas Fault, stretching from Point Mugu to the Arizona border, and he termed it a geological puzzle. Well, now we know why. It's the whole thing there. First of all, is a volcanic field. It's got a magma chamber under it. And of course, all these things with these mud pots and steam and fumaroles there, of course it's moving. We even have a geothermal plant there at Ridgecrest. We have a geothermal plant in Salton Buttes as well. Now, Jackson, writing for the issue of Science magazine at that time, says the bulge does not exist but results from errors in tolerance level of 3-meter rods used for the surveying. And in earlier reports, Castle said the bulge, centered 40 miles north of Los Angeles, has risen and dropped for some years, and he notes that similar uplifts in other parts of the world had preceded major earthquakes. Oh, well, of course. Up and down, major earthquakes, and we're not only talking about major earthquakes and deformation, we're talking about a subduction area and a volcanic area. So it's one of the worst areas in the world for earthquakes. Now the bulge, the Geologic Survey says, covers 32,400 miles and is 90 miles wide at certain points. It's identified by Castle and other scientists when they looked over some 10 to 15-year-old records, and they discovered the ground had an uplift several inches within the maximum area of uplift near the city of Palmdale, and that's why it's called the Palmdale Bulge, Palmdale, California, because the uplifted area straddles a large segment of the San Andreas Fault. That's why scientists were concerned the crustal deformation might somehow be related to development of a large upcoming earthquake. Large were meaning 7+ magnitude. Other scientists said it may be a slow earthquake. And we have learned that, yes, we have had slow earthquakes along the Garlic Fault, the creeping that they were talking about. So both of these teams were right at that time. Yes, there was a slow earthquake, a portion of the earth moving over a period of years rather than a few disturbed seconds of strong earthquakes. Castle said it could be migrating bubbles trapped beneath the surface of the earth. That, of course, also can be taking place. Or it could be that the bulge is concentrating itself in a very localized area. Or again, it could be the bulge is simply subsiding. And Jackson said it was never there in the first place. USGS, National Geodetic Society, several states, county, and local agencies began a more comprehensive study in 1978 and involved 300 specialists. And they determined the bulge developed from about 1959, and it reached its peak in 1974 with elevations, an uplift of up to 18 inches. So you can see that's quite a lot. Some scientists, including Castle, later lowered that estimate. Castle said the measuring equipment errors were trivial and cancel each other out, and he maintains the Earth rose up at least a few inches, and then it subsided again. So Dr. Jackson said, I find that it didn't go down, and moreover, it never went up. And Dr. Robert Mark said, who is a physicist, physical scientist at USGS, said, we don't understand it, and anything more than that is speculation. Okay, you don't understand it. But it's moving. They had unprecedented movement, and we're talking about the movement of the area recently, of course, all right, with cracking at Ridgecrest. The left-hand part of that crack was going northwest, and the right-hand side was going southeast, and it cracked that area. So there's a lot of movement today in that area, and we see that the Ridgecrest earthquakes jolted that whole area, and it's moving. We had some very big earthquake, a triple earthquake of 3.6 around Ridgecrest, and they seem to be increasing in strength. Now, also, the Palmdale Bulge, as we said, is a mystery. It's still a mystery. I don't know. I'm trying to find recent articles on that. They don't seem to be there. But we're going to look at the GPS on the Geodesy. The Palmdale Bulge, the uplift of the earth crust as much as 18 inches along the San Andreas. It did take place. And scientists were wondering if it was the harbinger of a giant earthquake or even a volcano. Yes, we have volcanoes all along the San Andreas, all along the Walker Lane fault system. They were uneasy in the aftermath of the 1971 Silmar quake that was destructive, and stories of West Coast disaster also trending in popular arts, whether it was the last days of the late great state of California motion picture earthquake, and various other. Okay, so where is this real-life landmass said to be rising ominously? It's about, as we said, 60 miles northeast of Los Angeles, and the 300 scientists, engineers who armed themselves with instruments to swarm all over for 3 months to determine what was going on there. They spent over $3 million there. Now, Glendale organization called Quake Watchers, and they warned that the importance of a Palmdale bulge concerned every Californian, not just Los Angeles. And it was the Times' John Dart who termed that one of the more unusual forays of faith. A healer drove to this area of Antelope Valley, where he performed certain rites over the Palmdale Bulge, predicting that it would miraculously go away. Now, scientists in 1978, plagued by bulky equipment and the worst weather in years, And the thing is that the measurements did not go well, according to reports. And what they did find is that the theory was that they were developing serious cracks in the area. Seismologist Susan Hughes wrote in her book, Predicting the Unpredictable, the Tumultuous Science of Earthquake Prediction. Now, what the teams that went there to examine the area found was that very strange things happened before and after they went. Maybe it was coincidence. The animals were behaving in a very, very strange way. Now, let's take a look ourselves at what's happening there with the geodesy. At Antelope Valley, California, this is where we have the area of the bulge. A portion of California constitutes the west tip of the Mojave Desert. There we go, that's not beautiful. And mostly, principal cities are Palmdale and Lancaster. Sorry about that. Let's go here. That's the Palmdale that we're looking at. And you can see this is one of the fastest growing cities. A couple of decades ago, it was the fastest growing cities in the country. It was so beautiful. The Valley region, Southern California, San Gabriel Mountains there in the back. And it's about 50 miles northeast of Los Angeles, which is south of that. And this is our area here, right here. Antelope Valley, as you can see, that's the Garlic Fault. And Los Angeles area, Ridge Crest right there. So it's basically in the volcanic field there. More pictures there. Joshua trees in the snow, isn't that beautiful? Okay, and the Canadian geese go there from Canada. In the winter, they go there for the south to have more warm weather. And this is Palmdale. A bigger picture of it. Okay, it's the same thing. Okay. Basically, that's where it is. Okay. Okay, now let's go to the geodesy. Oh, okay, no. All right, there we go. Okay, Google Earth. This is it right there. That's the San Andreas Fault. That's the Garlic Fault. This is the lava crater, the lava flow that we had. A beautiful picture of it. You can see it even from Google Earth. Okay, and this is the Walker Lane fault system. We're going to do another video on that because it's very important. It's not one fault, it's thousands of faults together, and that's why after the 6.2 July 3rd earthquake, it hit in Ridge Crest. I guess the pressure just released itself there because that's where it was to happen, you know, in a series of fault lines there. And Garlic Fault is locked with San Andreas right here, Garlic with San Andreas. And all these things have been rattled. Okay. This is where we had our triple 3.6, 3.4 earthquake yesterday, right here. Okay, now let's go to the geodesy so we can see what is going on with the movements there. Okay, here we are. Palmdale, as you can see, Palmdale. Oxnard is where we had our 4-point-something quakes recently, a couple of days back. Not good. And Long Beach, okay, Los Angeles. About 50 miles north of Los Angeles. And let's go to the south of Palmdale on the San Andreas Fault, okay? San Gabriel Mountains, let's go. What's happening there? Where's it going? Well, we know that it's going west and it's going north equally rapidly, as you can see, off the charts type of thing, from 2000 to today. Okay, 360 millimeters displacement. And sort of inflating, and then it deflated, and then it's basically level. I don't know what's happening here. Let's ignore that for the time being. So it's moving northwest. Let's take this one here a little bit more north of that. Again, it's moving northwest, and what's happening here? It's deflating here. It's deflating. Let's go here. All right, CHMS. Again, it's going northwest towards Seattle. Okay, look at this thing. What's this? That's not a mistake. Sort of deflating, and then it rapidly inflated seasonally. What's happening there? Now, it could be because of rains. Could be because of rains. Perhaps good rains, a great rainfall, caused the aquifers to fill and therefore caused the land to rise. And then it deflated again and then basically level. And let's go, because that's an agricultural area as well. Okay, let's go to this one here. Again, northwest. And what happened? Maybe they calibrated the instruments. Let's just ignore that. And let's go in a little bit more so that we can see the other ones behind. Get into the ones behind that. Okay, let's take this one. Lin J. Again, it's going northwest and basically subsiding. Basically a little bit subsiding. And let's take this one. This is Lancaster, it's not Palmdale, but it's close enough. Okay. Again, northwest. Palmdale. Let's see what's happening in Palmdale. And a little bit of uplift. And let's go here to Little Rock. Northwest. And a little bit of seasonal and uplift. And let's go here. P561, northwest. Lately it's a little bit of uplift. And let's go here, Little Rock area. What's happening there? A little bit of uplift. But it's moving northwest. Moving northwest. Did we see this one? There's movement there. Movement. And let's take, did we see this? Antelope Acres. Oh, that's deforming. Sorry, that's subsiding. Well, it's subsiding. We know that this is basically a lot of farming there as well. Maybe it could be the aquifer that's emptying. We don't know, but it is deforming nevertheless. And we have to keep in mind this is a very earthquake-prone active area, especially after the recent very big quakes in Ridgecrest, which is in a volcanic field. Okay, and basically, let's see what's happening here towards Arizona. This is Salton Buttes, as we see right there. They have a geothermal plant there, and across the border in Mexico. Let's see what's happening there, Salton Buttes. Whoa, okay. All right, it started going west. Northwest, and it's going west, and this is going sort of, started going down, south, and then started going west again. All right, let's take one of these. Going east, and then west. This is a very big increase here. Sort of seasonal deformation. Okay. Let's take one around Tucson, Arizona. Okay. All right. Okay, so we see that it's moving northwest. Moving northwest, Ridgecrest. Let's go to Ridgecrest. That's Death Valley. I don't want Death Valley. Okay, let's go to Ridge Crest. Okay, Ridge Crest, there we are. What's happening there? Let's take one, Searles Valley. And what's happening there? It's moving northwest, slightly, and a little bit of deformation, a little bit of subsidence. And let's take one, this one here, P570. Okay, again, it's going northwest, and it's inflating. Okay, we know that that's the cause of volcanic field, and we have earthquakes there. Except for the bulge, that is the magma chamber underneath, where we don't have earthquakes there. We have earthquakes around it. Let's go back. Here we go. Let's go in a little bit. This is Sizewell Berkeley. The blue are today's quakes, and the red are the past hour. Okay. And let's move in a little bit. Palmdale's right there. Okay. San Gabriel Mountains. Little Rock we saw before. And we have some earthquake activity there as well. Okay. Small earthquakes. Garlic Fault earthquakes on the Garlic Fault. And this is our Ridgecrest area. Owens Valley Ridgecrest area on the Walker Lane Fault system. This is the magma chamber right there, the bulging of the magma chamber. That's where we don't have too many earthquakes there. Oh, we had a lot of earthquakes here today. Kelso Range, that was from yesterday. Yes. Okay. This is where we had the triple earthquakes yesterday. Here, and these two, which were one in the morning, one in the morning and one in the evening. They were about, this was 15 minutes apart, and this one was like in the morning, 8:02 a.m., and this was later in the evening, about 14 hours later. So these were the triple quakes that took place yesterday that I had the video on concerning. You can see a tremendous amount of earthquake activity right there. Also volcanic field, just north of the magma chamber, the plume there, okay? So that's the story of our Antelope Valley, Palmdale. It's moving, and we have some deformation. And of course, they have told us that this earthquake activity will be ongoing for quite a long time yet, because Ridgecrest was a big earthquake. But it's not the fact that it's just an earthquake, it's also a volcanic area of the subduction zone. And it's also the same magma body that's feeding all of this west coast area, and also going into Salton Butte. It's coming here, Salton Buttes, all of this volcanic area, Long Valley Caldera, right there, the geysers, all these high threat volcanoes and Yellowstone have the same magma corridor that's feeding them, right there. Okay, and this is along this fault line, Mojave, Nevada, all this area, all this is the same magma body. Okay, I'll leave links below for you for this. And thank you, Shirley Williams, for bringing us up to, motivating us with the Palmdale Bulge. I'll leave links below for you for this. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.